Hey, what's up, guys? I'm gonna try and go through finding the surface area of this composite shape for you guys so that you can see how it's done one more time before you start getting your retest. So this composite shape is made of two different pieces. You've got the rectangular prism on the bottom and the triangular prism on the top. So if we were to draw out the two separate shapes, if I were to separate these two so that I can find their surface areas individually, let's do that first. So my first piece is going to be the rectangular prism. So bear with me, I'm using the computer here, so a little bit not as good as I would if I were trying it by hand, but it'll come out alright. So there's rectangular prism. So this is the first piece. We're going to analyze the surface area of this piece first, and then we'll do the same thing with the triangular prism, and then we can add those two together after. Once you've got the total, you subtract away the overlap. So this side here is 5 centimeters, this side is 8 centimeters, and the height is 6 centimeters. So, if I wanted to find the surface area of, say, this front rectangle, rectangles are found by doing area equals length times width. So, talking about this shape, this side right here on the front. So, area equals length times width. My length is 8 centimeters, my width is 6 centimeters, so we can do that. 8 times 6, that equals 48 centimeters, centimeters squared, I should say. So that's that side. Now notice that it has a mirror. This is one of the things I talked about today. The other side is the exact same dimensions. So this side here is also equal to the 48 centimeters squared. So we can times this by 2 for a total of, that would be 96 centimeters squared. So that's that side. Now, there's also there's other sides to this. So let's do the sides. The left side here and the right side of the rectangular prism. So if I were to identify those with the purple, so this side here and this side over here. So those two sides are the next ones that I'm going to be doing. Again, they're mirrors of each other. They're the exact same. So if I find the area of one of them, I have the area of the other. So area of those two, this rectangle is a 5 centimeters by 6 centimeters. 5 by 6 centimeter rectangle. So still length times width. Sorry about the writing, I know it's not the clearest, hard to write with a mouse. So this is a 5 by 6 rectangle, which gives us 30 squared centimeters. And again, it's not just one of the sides, it's also this one over here is also a 6 by 5. It's the same thing. So we can also multiply this by 2. Let's write that in the right spot. So multiplied by 2 for a total of 60 centimeters squared. Perfect. That's 2 of our parts so far. That's 4 of our sides that we've accounted for. We still have the top rectangle though. So the top is this 8 by 5 rectangle. So this piece right here, 8 by 5. This rectangle on the top is the next one in question. So it also has a mirror. This one on the bottom, it's an 8 by 5 rectangle. They're mirrors of each other. Take note of that. So the 8 by 5 is mirrors of each other, so we're looking for 2 of them. Let's find out the area of just one of these. It's 8 by 5. So area equals length times width, which equals 8 times 5. 8 times 5 equals 40 centimeters squared. squared. Again, that the top piece here is an 8 by 5, which means it's 40 centimeters squared, but it's not by itself. It has a mirror on the bottom here, so we multiply that by 2 to get our total of 80 centimeters squared. So our total surface area for this whole rectangular prism is going to be the sum of these three parts, 96, 60, and 80. These are my front and back, these are my left and right, and these are my top and bottom. All 6 sides of the rectangular prism. Add them up and you get your total. So let's do that. So 96 plus 60 plus 80 will give us 236 centimeters squared. That's the first piece. So let's skip over to the next slide and we'll do the triangular prism on the top. So that's still all there, but let's do the triangular prism. So triangular prism, it's like this with that. Connect, connect, connect. Now they've shown that these two little lines here mean that these two sides are the same. This one and this one are the same. They've shown that the height here is equal to 4 centimeters. They've shown that there. The height is 4 centimeters. So we also know that this entire distance across here is 8 centimeters, which means if these two are the same, that means that this must be split in half. So this 8 centimeters, half of this triangle from here to here would be 4 centimeters. So if this is 4 centimeters, we've got the 2 pieces we need to find the third side of a triangle. For your triangular prism, the first thing you should do is make sure that you have all 3 sides of your triangle. If we find out this one, we'll know this one. So this was again 4 centimeters. So this is a 4 by 4, a triangle with a base of 4 and a height of 4. So we need to use Pythagorean's theorem to find out this third side. This third side is called the hypotenuse. So Pythagorean's theorem is a squared plus b squared equals c squared. So the c, let me actually designate that with orange here. So this the hypotenuse, the longest side, is your c. So we want to find out what that is. So let's substitute in some numbers here. My one side is 4 squared, so that's 4 squared, plus my other side is also 4 squared. So this one for the bottom, and the other side, this 4 is for the other side. So that equals c squared. Let's do that. So 4 squared, 4 squared means 4 times 4, so that's 16, plus another 4 squared, another 16, that's equal to our c squared. And then, so 16 plus 16 is 32, equals our c squared. But we want to find out what c is. We want to find out what the length is. C, not c squared. C squared is talking about this square that would come off of it. 32 is equal to that square. We want to find out what one side length is. To do that, we need to square root. So to find out what c squared is, we need to square root our both sides. So square root 32, square root c squared. Squaring a number and then square rooting it gets us right back to the original number. So square rooting c squared gives us our c. That's what we want. Now we just need to find out what the square root of 32 is. Pull out a handy dandy calculator for that. 32 square root. Just one decimal value is enough. So 5 point, rounded up to 7. 5.7 is about what 32 squared is. So 5.7. That's what this value is. So that side is about 5.7 centimeters. Again, we rounded, which means this one is also that 5.7 centimeters. 5.7 centimeters. Cool. So we've got all the pieces of our triangle. Now we can start finding the surface areas of these sides. So let's go back. Looking at our triangle, we know that the height is 4 centimeters. The base of this entire side is 8 centimeters. Don't use the 4. The 4 was only halfway across. Remember that. The 4 is only halfway across. We want to use the 8 because that's the base of the triangle, not just half of it. And then along here is going to be the same as a rectangular prism, the 5. So this side here, the depth of our triangular prism is 5 centimeters. So that's all we need. These two sides are both 5.7 centimeters. So, and this one here is also 5.7 centimeters. That's what we found out from Pythagorean's theorem. So let's find out our 5 sides. Triangular prism has the 2 triangles on the front and the one on the back. Then we also have 3 rectangles. There's the one on the top here, there's the one on the back, and there's the one on the bottom. So let's do our 2 triangles. We'll show that in green here. Our 2 triangles are these 2. So we will do those. Triangles are found by doing base times height divided by 2. So our base, our entire base for this triangle is 8 centimeters, and the height is 4 centimeters. So base times height is equal to 8 times 4 divided by 2. 8 times 4 is 32, divided by 2 equals 16. So 16 centimeters squared. That's for one of our triangles. The other one's the same. It also has a height of 4. It also has a base of 8, since they're mirrors of each other, so we can multiply this number by 2. That gives us a total of 32 centimeters squared. Again, this number is for our triangles. So let's do some more here. Oops. Fix that. 32 centimeters squared. So let's do our rectangles. So let's first identify our rectangles. So we've got this one in the front here. Let's do them one at a time. This one is a 5 by 5.7 rectangle. So area of a rectangle, I suppose I should do this, area equals. So area equals, for a rectangle, length times width, which is equal to, in this case, 5 times 5.7, which is going to equal 25.35 centimeters squared. Awesome. Now, this other one here, this other triangle at the back, it's also a 5.7 by 5 rectangle. So this one back here at the back is a 5.7 by 5 rectangle. So again, and that should be expected because we've got these 2 side lengths are the same. So we can multiply this by 2 to get the other rectangle. If these 2 sides were different, you would have to, if these 2 sides were different, you would have to do a separate area for that rectangle. But since they're the same, no need to do it. We can just multiply this by 2, which would give us 50.7 and centimeters squared. Cool, just one to go. We also have one more rectangle here. Do this one in pink. at the bottom. This one is an 8 by 5 rectangle on the bottom here. 8 by 5 rectangle. So we can do that. The area is equal to length times width, and that is 8 by 5, so 8 times 5 equals 40 centimeters squared. Done. So we've got our 5 parts here. So I suppose I should highlight them. The 40 centimeters squared, that represents our one bottom rectangle. Then we've got the two sides, the top and the back. This rectangle right here, the 5 by 5.7, and this one back here, also 5 by 5.7. 5 by 5.7 rectangle at the back. So those are the two of them. We added those together. So 2 triangles, 2 rectangles, 1 more rectangle. That's our 5 sides. 1 in the front, 1 in the back, and then the 3 rectangles. 5 sides. Add them all up. So total surface area is equal to 32 plus 50.7 plus 40, and our total is going to be 122.7 centimeters squared. Ta-da! So we've got our total for our triangular prism. Let's just go back here really quick. Here is our rectangular prism. We need to add them both together. So our total between them, so surface area is equal to 122.7 plus, and the other one was 236 centimeters squared. Oopsie. You can add those two together. Let's use our calculator for that and make it quicker. So 122.7 plus 236, 258.7, or 358.7 centimeters squared. Awesome. So that considers if our triangular prism was by itself and a rectangular prism was by itself. But we know that they're not actually by themselves. The top of the rectangle here, this piece, is actually covered up. This one that's in green, this is covered up by the triangular prism. The triangular prism is actually sitting on top of that rectangle. So we need to remove that rectangle. Likewise, the bottom piece of the triangular prism, it's also covered up. It's covered up by the rectangular prism on the bottom. So we also need to subtract that. So they're the same though. This rectangle here is the exact same as this one. This is an 8 by 5 rectangle. This one is also an 8 by 5 rectangle. So we can find the area that the overlap is, multiply it by 2 because it's affecting the rectangular prism and the triangular one. So that will keep it in green. The area, whoopsie, is equal to length times width, which is equal to 8 times 5. That's equal to 40 centimeters squared. Now there's 2 of them. Remember, it's not just affecting the rectangular prism, it's also affecting the triangular prism. This piece right here, it's an 8 by 5 rectangle. It's part of the rectangular prism and the triangular prism, so we need to multiply that by 2 for a total of 80 centimeters squared that we need to take away. That's the overlap. So we've got our surface area, which is 358.7 centimeters squared, and we need to subtract away the 80 centimeters. That is the overlap. So our grand total is going to be, we'll take that, subtract away the 80, And we're left with 278.7. 278.7 centimeters squared. Done.